The consumer's problem. Suppose we have a consumer named Chris. He has an income of $20. There are just two goods in the world, apples, which cost $1 each, and bananas, which cost $2 each. The consumer's problem, what is it? Well, it is this. Given the consumer's income, $20 in the case of Chris, and given the prices of goods, as indicated here, how much of each good should Chris buy? So Chris thinks to himself, how many apples and bananas should he buy? How might we analyze this problem? Well, one way to do it is to use a graph. Here's what the graph will look like. On the horizontal axis, we'll have apples, and on the vertical axis, we'll have bananas. That's all for the setup of the graph. It's that simple. I'll stick at the top right of the screen some useful information. This is just information on Chris's income, $20, and the prices of apples and bananas. Now, back to the graph. The points on the graph are going to be what are called consumption bundles. Here's an example of a consumption bundle. It's the point highlighted in red. This is the point 10, 1.5. That's 10 apples and 1.5 bananas. So what exactly is a consumption bundle? Well, a consumption bundle is just going to tell us how much of each good the consumer might consume. So the example we just gave, 10, 1.5 is an example of a consumption bundle. In the language of mathematics, we say that this is a vector. More specifically, it's just a vector that specifies a number of apples and a number of bananas. But don't worry if you don't know what a vector is, it's just a technical term. Let's now look at another example of a consumption bundle. Let's look at the point that's highlighted in blue. This is the point 5, 3. That's 5 apples and 3 bananas. So if we say that Chris is consuming at the blue bundle, what we mean is that he's consuming 5 apples and 3 bananas. Let's now move on to introduce a new term. That's feasible consumption bundles. The word feasible here just being a fancy synonym for affordable. So when we say a consumption bundle is feasible, we just mean it's affordable. So for example, the first consumption bundle that we looked at, is it a feasible consumption bundle? The answer is yes, and the reason is simple. Because 10 apples at $1 each, that's $10, and 1.5 bananas at $2, that's another $3. Altogether, this bundle adds up to $13. And $13 is less than Chris's income of $20. Therefore, this is indeed a feasible or an affordable consumption bundle. Similarly, if we look at our second example of a consumption bundle, the blue bundle, and we ask, is this a feasible consumption bundle? Again, the answer will be yes, because we can quite easily compute that 5 apples at $1 each, that costs $5, plus 3 bananas at $2 each, that's $6. Altogether, this bundle is going to cost Chris $11, and that's less than his income of $20. So yes, it is indeed an affordable or a feasible consumption bundle. Let's now look at yet another example of a consumption bundle, the bundle that's highlighted in yellow. This is the bundle 10 apples and 10 bananas. Is this a feasible consumption bundle? Well, it turns out that it isn't, because 10 apples and 10 bananas are going to cost altogether $30, and that's more than Chris's income of $20. Let's look now at yet another new term, and that's a just feasible consumption bundle. What we mean by just feasible consumption bundle is a bundle that's just affordable. Or in other words, it's a bundle that costs exactly the consumer's income. So for example, the red bundle is not a just feasible bundle because it costs $13, which is less than Chris's income of $20. Similarly, the blue bundle is also not just feasible because it costs less than $20. The yellow bundle is not feasible at all in the first place because Chris cannot afford to buy it at all, and so it is also not just feasible. So, what's an example of a just feasible consumption bundle? Well, suppose Chris spends all of his income on apples. Then what he'll get is 20 apples and 0 bananas. And that corresponds to the pink point which we've just highlighted. This is an example of a just feasible consumption bundle. Similarly, suppose instead that Chris spends all of his money on bananas. Then what he's going to get is 10 bananas and 0 apples. And this corresponds to the orange point that we've just highlighted. So this is a second example of a just feasible consumption bundle. The next thing we'll introduce is the notion of a budget line. The budget line is going to look like this. It's a straight downward sloping line. So what precisely is the budget line? Well, the budget line is just going to be the set of all just feasible consumption bundles. So the orange and the pink bundles, which we just looked at, they each cost $20. That's Chris's income. so they are each just feasible. Therefore, they are both on the budget line. In contrast, the blue and red bundles are not on the budget line because they cost less than Chris's income. Similarly, the yellow bundle is also not on the budget line, but this time for a different reason. It's not on the budget line because it costs more than Chris's income. So, why is it going to turn out to be the case that if we try to construct the budget line, that is to say, if we try to plot out all the just feasible consumption bundles, they will all happen to lie on the same straight downward sloping line? Well, let's see. So suppose Chris is on the orange bundle, that's 0 apples and 10 bananas. And now he's already spending all $20 of his money, right? So he says to himself, okay, he wants to buy 1 additional apple. However, he was already spending all of his money. So in order for him to buy 1 additional apple, he needs to free up $1 of income because that's what apples cost. Where is this $1 going to come from? Well, it can only come from him cutting back on his consumption of bananas. And since each banana costs $2, he needs to reduce his consumption of bananas by precisely half. And so where he'll end up at is at the purple consumption bundle that I've just highlighted. This is the bundle 1 apple, 9.5 bananas. This bundle is also a just feasible bundle because here Chris is spending all of his money. So you can see that if we keep repeating this exercise, we'll keep generating more and more just feasible consumption bundles, and they will all happen to lie on the same straight downward sloping line, which we call the budget line. And the slope of the budget line is going to have a magnitude of half. Where does this magic number of half come from? Well, in fact, it's just the ratio of the price of an apple to the price of a banana. Apples cost half as much as bananas. So in order for Chris to get 1 additional apple, he needs to give up half a banana. This reflects precisely the trade-off between apples and bananas. To get 1 more apple, he must give up or trade off half a banana. Let's end this video by quickly noting that the ratio of the price of an apple to the price of a banana is quite logically enough called the price ratio.